Question 21C says a third line L3 passes through -4, 1 and is parallel to L1. Find 1. The equation of L3 in the form y equals mx plus c, where m and c are constants, and then 2. The coordinates of the point S at which L3 intersects L2. So let's start with the first part, 1, where we're to find the equation of L3 in the form y equals mx plus c. So the information that we've been given is that L3 is parallel to L1. If L3 is parallel to L1, that means that the gradient of L3, M3, is equal to the gradient of L1, M1. The gradient of L1, which we discovered in the previous part, is 2/3. That means that the gradient M3 of L3 is also 2/3. So to find the equation of L3 in the form y equals mx plus c, we first need to substitute these points of the line that L3 passes through -4, 1 for y and x in y equals mx plus c. That will give us a c, or the y-axis intercept. And then, as we already know m, we can just put those together to find the equation for L3 in the form y equals mx plus c. So let's write that down. Y equals mx plus c, and our y is 1. 1 is equal to 2/3 times by -4, and that gives us our c. So let's rearrange this on this top line. So we have c is equal to 1 minus 2/3 times by -4. 1 minus 2/3 times by -4. So let's first work with this bit here. So 2/3 times by -4 gives us -8/3. And then since we have a minus and we're subtracting it, then we get a plus. So we have 1 plus 8/3. 1 can also be written as 3/3. We have 3/3. 3/3 is the same as 1 whole, plus 8/3. And that is equal to 11/3. So we have our c, or our y-axis intercept. We also have our gradient m. So let's put these together and find the equation for L3 in the form y equals mx plus c. So let's substitute 2/3 and 11/3 for m and c respectively. So we get y is equal to 2/3 x plus 11/3 for the equation of the line L3. Let's move on to the second part. The second part says find the coordinates of point S at which L3 intersects L2. So what is the equation for the line L2? The equation for the line L2 is y is equal to -3/2 x plus 3/2. So that's the equation for the line L2. The equation for the line L3 is y is equal to 2/3 x plus 11/3. So what we're going to have to do is to equate these two equations, the equations for the line L2 and L3. When we equate them, we'll get an equation in terms of x. From there, we'll solve for x. Once we've found the value for x, we can substitute that value for x into either the equation for line L2 or line L3 to find the value for y. So let's do that. First, let's equate these two equations, L2 and L3. So we get -3/2x plus 3/2 is equal to 2/3 x plus 11/3. So what I'm going to do is I'm going to move the x's all over to the right hand side, and I'm going to move all the constant terms over to the left hand side. So I get 3/2 plus 11/3 is equal to 3/2x plus 2 over 3x. 3 over 2x plus 2 over 3x is equal to 13 over 6x. 3 over 2 subtract 11 over 3 is equal to minus 13 over 6. That means that it's at the point where x is equal to minus 1 where L2 and L3 intersect. So now we know the x-coordinate of point S. Now let's find out what the y-coordinate of point S is. So let's substitute x is equal to minus 1 into y is equal to 2/3 x plus 11 over 3. And that's the equation for line L3. So when we do that, we get 2/3 times by minus 1 plus 11 over 3. And that gives us 11/3 minus 2/3, and that is 9/3, which is the same as 3. So it's at the point where x is equal to minus 1 and y is equal to 3 that L2 and L3 meet. So x has the coordinates minus 1, 3.